Hey, you came back. All right, let's do part two. So we left off with tire ratings, sidewall information. I was just getting ready to show you passenger tire load ratings. Okay, so that's basically right here. This number, what does that mean? Here is a chart for passenger tire load ratings. So you look at that number, that as in the previous page, it was an 89. That says this tire can handle 1,279 pounds or 580 kilograms. That's per tire, remember. So if your vehicle is perfectly balanced 50-50, you can divide the weight by 4 and figure out what each tire is going to handle. Now, of course, you know that's not quite the way cars are designed, but it gives you an idea of what these tires can handle in weight. So again, you got to pick the appropriate tire based on what you're using the tire for. If it's a truck, you want an LT, not a passenger. You want the thicker, more rugged sidewall because you're going to give up the ride for function, right? You want it to handle more weight. So you'll see the code, the load will go up. The load number is going to go up by design on an LT tire. But make sure all of that meets the minimum requirement and what the OE specified to make sure that you're safe. So again, here you're looking at the light truck tire load rating. Here's your load range. Here's your ply rating, how many plies, 4, 6, 8, 10, 12, maximum load pressure, etc. Let's see if you can find it right here. Max load, 2250 pounds, right there. Okay, so again, you're looking for those load ratings. Okay, and then there's the speed rating. So that letter that was next to that number, the number was a load rating. Then there's a letter next to it. Let's go back and see what we had. H. So this tire has an H. Let's go look at H. Where's my H? There it is. So 130 miles per hour or 210 kilometers an hour. So 130 miles per hour, I'd say that's pretty good. H is going to be good enough. For what reason do you need to go 130 in the continental United States? You can't do that. So you're good, right? Obviously, I don't want a tire that's going to go 55, 65 miles an hour because that's max speed. And I know I'm not going to go over 65 because that's the federal law speed limit. Some places are 75, but you know, you get the idea. You don't want to cut it too close. So if you're looking at high performance cars with Z-rated tires, over 149 miles an hour, maybe track days, I don't know when you would be able to use that. So are you wasting your money? I don't know. You do get a quality tire, but just showing you what all these numbers mean. Another number many people don't know about is the DOT, Department of Transportation number. It tells you a lot. So it'll tell you the manufacturer's plant ID. It's going to tell you the tire size code, tire type, and what I like, the date. So when I'm purchasing tires, I want to make sure they all match and they were made the same time. I don't want 3 new tires and 1 old one, or 3 old and 1 new, or 2 old and 2 new. I want them all manufactured in the same plant at the same time so they wear consistently. One isn't rotted before the other 3, and it's a 4-digit number. You'll see 0305. That is the 3rd week of 2005. So that's how that number means. And if you look at your DOT number and this area is blank, look on the other sidewall. So it's only stamped on one side of the sidewall. So check the other side if you don't see it. Again, back to tread wear, 100, 200, 300, 400. That's how long the tread lasts. Lower is soft, wears out fast. Higher the number is hard, lasts longer. Traction, A, B, and C rating. For traction, 40 miles per hour, wet straight line stopping. Temperature, A, B, and C. It gives you this temperature rating over 115, 1 to 115, 85 to 100. So, not the best numbers to dictate what a tire can and can't do, but it gives you kind of tries to compare apples to apples. And then, of course, you got specialty tires. So, puncture sealing tires, they got gooey stuff in the tire. Mud and snow, as we mentioned earlier, all-season terrain. You have, again, with all-season AT tires, you have mud terrain, you have hybrid terrain. You got a lot of different style rubber tires, how aggressive the tread is depending on what you're doing. You know, if you're going rock crawling and you want some big knobby tires, your MTs up in the mud and the rock, or do you want a highway tire, an HT? Do you want an all-season tire, an AT, kind of all-terrain, kind of gives you a little bit of everything, right? Kind of a C or B grade tire. It won't really go rock crawling, but it's not going to be the best for highway. It kind of does it all. And then, of course, you have run flat tires, to where if they go flat, there's no gooey stuff, but they have like really stiff sidewall or a ring, a donut on the rim that's going to allow you to run with no tire pressure to get to where you can be safely repaired. Also, look right here, you have kind of these the way the tread design is, as it hits this water, it suctions the water up and spits it out. And then the tread can also be designed to kind of redirect the water out of the path of the tire so the tire can touch the ground quickly and not what's called hydroplaning. Hydroplaning is when the surface of the water, the tire will crawl up on top of the surface of the water and kind of, it's by definition a hydroplane, it's going to disconnect from the surface of the road. So it's going to go up on top of the water, and you're going to lose traction obviously because now you've got water between the tire and the road. Here's one of those run flat kind of old setup. You got that donut kind of ring inside the rim, so when the tire runs flat, it sits on this so it doesn't damage your rim, and you can drive to where it's safe and convenient. And again, I also tell students, I tell family, friends, etc., if you have a tire that's blown out, do not stop on the highway or freeway and get yourself killed. You can repair a rim. You can't repair yourself that easily. So get to somewhere that's safe. Either call roadside assistance or put your spare tire in if you feel comfortable. But first and foremost, you got to be safe. A rim can be replaced. So make sure if you have to drive it down the road, drive it down the road. But make sure you pull over in a safe spot. That's a flat level ground that you can jack up on, chock the wheels, and repair your spare as taught, or call roadside assistance. This little doohickey right here, this is what I sat behind for a good solid year as a tire buster. It's a tire machine to mount and dismount tires on rims. So that's a fun tool you'll use in the shop next on the chassis class. Either run flat style, here's that cross section again right here, or it's going to have some type of goo in the tire. And you'll notice a lot of cars now don't come with spares. They come with a pump and a sealant. So they'll have something you spray in the tire and then a pump to pump the air. This is going to get you by for a slow leak. Obviously, if you have a gash or a blowout, this is going to be useless. And then here I was talking about the tread design, that as the tire rotates around, it's going to actually kind of spray the water out of the tread center section, which allows the tire to make contact with the pavement. If you look at these tires, it tells you rotation and direction. So these ones you couldn't cross rotate. These would have to stay basically on the same side of the tire if that was the case, on the same size of the vehicle, sorry. You wouldn't want to be moving these around to where they face different directions. So pay attention to marking on the sidewalk before rotating tires, and size. So if they're rotational and they're staggered, meaning the front's smaller than the back or back's bigger than the front, however you want to look at it, you can't rotate them. If they're the same size and not rotational, then you can do the cross a drive as mentioned in the previous lesson. Some tires are what's called, like this tire here is symmetrical, they're the same on both sides. Some are asymmetrical, meaning they're different tread on the inside and outside. Those can be rotated, but it's up to the tire mounter to make sure the outsides are all the same. So again, back to mud and snow, four-wheel drive, 4x4, how much tire, what compound, MTs, HTs, ATs, all these different tire designations. Basically, you want to try to get OE tire, and I get it. You know, you're going to want to modify that based on your use, but just be aware that there's going to be certain problems that'll happen if you change tires. One of which, and not the least, is center of gravity is going to go up, which means your capability of rollover is going to be significantly higher. So be aware of that. And a couple more things we'll talk about in a minute. So how do we know what size? Again, back to that placard. It tells you the OE tire size right here. It tells you the OE tire pressure right here to run. Remember, you make sure you read this pressure on the door placard and then compare it to the tire. It shouldn't be higher than the tire's PSI. Again, this is the recommended tire pressure, but the one on the tire is that's the max pressure the tire can handle. So to put it again a different way, this is the tire pressure you run your tires out in your car as per OE recommendation right here, as long as this number isn't higher than the one on the tire. Okay, these are the size of the tires, the front, rear, and spare, speed rating, and the rim size, and now it all kind of makes sense since we went through that. So a couple things: if you change the tire size, your PCM calibration will be wrong, which could cause smog failure, your transmission to shift funny, bad fuel mileage. Again, you can have speedometer will be off, you get speeding tickets, your odometer could be off. These can be programmed, but it takes either a special shop and or the dealership. Depends on the car if the dealership can do it. Sometimes it needs to be an aftermarket program tool, and they could be, if you purchase them, they could be $400 or $500 at this time. But you might want to just pay a shop $100 if you're going to do it once. So it's really up to you. And again, this is all, if you're lifting up your vehicle, putting in aggressive tires, you're understanding the risk involved that the vehicle can tip over. It can handle differently than OE. You're going to have different tire PSI. Your speedometer is going to be off, just like everything we said here. So you're weighing in those pros and cons and saying, I'd rather have big tires, lifted rig, and want to go rock crawling versus the OE size tire. Again, it is going to be not as safe and it can tip over. So take all that into perspective, caution, basically just understand what you're doing. You're modifying things. So I mentioned earlier that we could put nitrogen in these vehicles versus shop air or ambient air. The reason why some people do that is the nitrogen molecules are fatter than air. No moisture in compressed nitrogen, unlike atmosphere. They're identified by green valve stem caps, and some consider them snake oil marketing. Again, nitrogen is going to be a bigger molecule that's going to be more stable. It doesn't expand and contract as much as oxygen, and throughout the temperatures, it just becomes more stable. Shop air or ambient air is going to change with heat. So if you're going to have cold air versus hot air, the pressures in the tire can change. That's why we always recommend checking the pressures cold, because that's the lowest the pressure will be. As it heats up, it's going to increase in pressure because the molecules are basically taking up more space. Kind of, it's a little bit different than that, but that's the idea. That's the best analogy. So tire pressure monitor. If you've seen this light in your dash and it was on solid, that probably means your tire pressure is low on one of your tires. The vehicle's monitoring the pressure in the tires for you. If this is on solid, it's low. If it's blinking, there's a fault. So that does mean something different. How does a tire monitor pressure? Well, I'm glad you asked. There's two different ways. Direct, as in a sensor in the tire, and then indirect, where the vehicle uses the ABS wheel speed sensors to verify rolling diameter. Meaning, a tire that's flat is going to have a different diameter than a tire that's full. The computer can interpret that wheel speed sensor and actually understand or determine if the vehicle, if that rim is low in pressure. It can actually infer that based on the way the wheel speed sensors showing its voltage values. So here's one style of tire pressure sensors that's direct. It's part of the valve stem. There's a sensor in that box. This actually measures pressure in the tire area, you know, where the air pressure is, or it can be clamped on. So it's either in the valve stem or it's a clamp on. So anyway, understand that you have to reset the light, or it can reset itself. So most vehicles, if you run all the tires up to OE pressure and then go drive it about 25 miles per hour, it will reset itself. If it is a fault, as in blinking, that's a DTC. You'll need a scan tool. And there are some special resetting tools that you don't have to go drive the vehicle. It dictates on manufacturer. So read your service manual and it'll tell you what you have to do. One point of caution is don't use liquid tire sealers inside here. It will ruin the sensor. With that said, if you need to, in order to fix a hole and get home, do it. The sensor is about $100. You know, that's way cheaper than a tow. So go ahead and do it. Just don't do it just because. I would use it on an emergency situation only for me. But again, use it if you need to, but don't if you don't. Because understand you will probably ruin the tire pressure sensor if you put that tire sealant and gunk in there. So we got rims, come in stamped steel, cast aluminum, forged aluminum, pressure cast aluminum, chrome plated, magnesium, and they vary based on lug nut design. So here's a cross section of a wheel and different lug nut designs. You have this conical tapered one, and then here's a shank flat one. There's also a ball seat where this is kind of round. The point is lug nuts aren't all the same and they don't match every rim. Make sure your rim and your lug nuts match and they're torqued to specification in a star pattern. And then here is kind of your offset of the rim. Here's the flange, and then you got your offset. So here's your center. This is a positive offset and a negative offset. You can see where that flange is changing. This will push the rim in and out of the wheel well for front wheel drive or rear wheel drive vehicles, or like 4-wheel drive. They might push that back spacing, push the rim out so you can have bigger tires. That basically concludes tires and wheels. You did it. You listened to me for 2 videos. I'm proud of you. If you have any questions, email me. I know it seems kind of fast, but thank you.